potential, but say first question. A spherical conductor of radius r placed in air is given a charge q. Then the potential at a point inside the conductor and at a distance r by 2 from its center. As it is given the potential at a point inside, the distance won't matter. As we know, the potential at all points inside the spherical conductor remains same. Therefore, the potential 1 by 4 epsilon naught q by r is always same. What is the potential on the surface also? Therefore, for all points inside, potential is 1 by 4 epsilon naught q by r. Therefore, the option for this is first one. Now, going for the second one. The electric charges 10 microcoulomb, 5, minus 3 and 8 are placed at corners of a square of side root 2 meter. Let me write the figure first. Say like this. And we have charge 10 here, we have charge 5 here, minus 3 and 8. And side of this square is given to be root 2 meter. We are asked to calculate potential at the center. Say we call it as P, and we call the first charge portion as A, B, C and D like this. Now as we know, potential is simply addition of potential due to all charges. Therefore I write, instead of 1 by 4 epsilon naught, I straight away write down 10 raised to 9. And now I write down the charges. Since all the charges are microcoulomb, I write 10 raised to minus 6 also taken out. Now I write first 10 microcoulomb and its distance from the center is AP, plus 5 by distance is BP, then minus 3 distance is CP, plus 8 distance is TP. Observe, AP, BP, CP and DP are all same. They are off diagonals and we can calculate them as, say like this. Just observe, AC by 2 is AP or BP or CP or DP. AC is root of root 2 square plus root 2 square by 2, which amounts to be 1. Therefore, our final answer will be 9 into 10 raised to 3. In the denominator, AP, BP, CP, DP are all 1, so taken out. In the numerator, 10 plus 15 plus 8, 23, minus 3 is 20. So I take this as 20. Now, we can write the answer 18, 10 raised to, say 180, 10 raised to 3. That means 1.8, 10 raised to 5 volts. So option 4 is correct. Now going for the third question. Observe, as we come across, actually as we had come across in some such combination of drops case in the previous sessions, here also n identical mercury droplets charged to same charge potential V coalesce to form a bigger drop. The potential of the new drop, say we can simply write potential of big drop as 1 by 4 pi epsilon naught q by r, where q is charged on big drop. But we know as each small drop is charged to small q, we can write it as 1 by 4 pi epsilon naught nq due to additive property of the charge, where q is charged on each small drop, or from the volume calculation we can show n to the power of 1 by 3 into r, where small r is the radius of the small drop. Therefore, we can simply write 1 minus 1 by 3 is 2 by 3 into V small drop, because 1 by 4 pi naught q by r will give us the V small drop. Therefore, option 2 is correct. Now going for the fourth question, we read, a ball of mass 1 gram and charge 10 raised to minus 8 coulomb moves from a point A whose potential is 600 volts to point B whose potential is 0. The velocity of the ball at that point B is 20. The velocity of the ball at A is asked. So we simply calculate work done is change in kinetic energy, that is W equals delta EK. W is given by potential difference into charge moved. So VA minus VB into charge moved is Q. Kinetic energy is half m V square minus final velocity square minus half m initial kinetic energy. Now if I write all these things, this side we have 600 into 10 raised to minus 8. On this side we have half m taken out. V square, say final velocity 20 centimeters is given. If I write it in meters, 0.2 meter per second square, so 0.2 square minus u square. Now, if we simplify all these things onto the right hand side, we write 1200, 600 into 2, 10 raised to minus 8 whole divided by mass is 1 gram, means 10 raised to minus 3 kg, which is equal to V square is 0.2 whole square. That means 4 into 10 raised to minus 2 minus u square. Now we simplify all these things. Also 1200 minus 8 means 1.2 10 raised to minus 5. This I can simply write it as u square as 4 into 10 raised to minus 2 minus 1.2 into 10 raised to minus 2. So which amounts to be 2.8 10 raised to minus 2 u square. Therefore u will be 16.7 centimeters square per second, as 2.8 square root into 10 raised to minus 2 square root is 16.7 by approximations. So option 3 is correct. Option 3 is correct. Now going for the fifth one. The potential to which conductor is raised depends on the amount of charge, that is correct, geometry and size of the conductor. Definitely shape and size also matters. Therefore amount of charge is actually a dependent factor for the potential, and geometry, shape and size also a matter. Therefore both 1 and 2 are the options. Now going for this, the work done in carrying a charge q once round a circle of radius r with charge q at the center, that is like this, q at the center, and we have a circle there on which a charge small q will go around. As the electrostatic force is conservative force, the work done depends only on the initial and final portion. As it moves on a circle, there is no work done. Therefore option 4 is correct. Work done is 0. Now going for the 7th question. The insulation property of air breakdown at 3 into 10 raised to 6 volt per meter. That means at electric field 3 into 10 raised to 6 volt per meter, the dielectric breaks down take place. Maximum charge in coulomb can be given to a sphere of 10 centimeter radius. That means we have to write the expression for electric field as 9 into 10 raised to 9 q by r square. Substitute everything, we will get that left hand side 3 into 10 raised to 6, right hand side 9 into 10 raised to 9 q to be calculated. Radius 10 centimeter means 0.1 whole square. Now if we do it like this, say 3 3s are 9 there. Now I can write simply q as 10 raised to 6 0.1 whole square divided by 3 into 10 raised to 9. Now Simplifying these things we get, observe 1 by 3 is there and all other things are in terms of 10. So simply we can choose at this point without further calculation option 3, because 1 by 3 is 3.33. So it is option 3 is correct. For the clarification we can show it like this: 1 by 3 into 10 raised to minus 3 going over there, 0.1 10 raised to minus 2, so 0.33 into 10 raised to minus 5, so 3.3 10 raised to minus 6. That is the calculation. But in the exam this part is not required, only at this stage as you came to know. So 1 by 3, that is 3.3 or 0.33, only the option that have 0.33 is that one, so you can take that. Now going for the 8th question. Now the potential of electric field produced by a point charge at any point xyz is given by 3xy plus 5. xyz are in meters and v is in volt. The intensity of the electric field at minus 210, say observe v is a function of x. Therefore electric field intensity is written as minus dv by dr. Here as it depends on only on x, I write dv by dx. Now I substitute for v and differentiate. 3x square plus 5 by dx. As y and z are not there, I have eliminated them. Now E equals minus 6x is the differential at minus 210. As y and z are not there, E equals minus 6 minus 2, that is 12. So option 1 is right. Option 1 is right. Say 9th question. As I told you in one of the previous classes, we have to use one good idea here. A conducting sphere of radius r carrying a charge capital Q is connected to an uncharged conducting sphere of radius 2r. The charge flows between them, say one small, one big. This is 2r and this is r. Now we are asked to calculate, once we connect, what is the charge flowing if the second conductor is uncharged. That means once you connect them, the potential becomes equal, as we said in one of the classes. Therefore I write down, after separation, potential of small sphere must be equal to potential of big sphere. Say potential of small sphere can be written as 1 by 4 pi epsilon naught Q1 by R equals 1 by 4 pi epsilon naught Q2 by 2R. Observe, Q1 and Q2 are the charges after connection and after the connection. Now we also know, according to law of conservation of charges, Q equals Q1 plus Q2. As in the beginning no charge is there on the bigger sphere, what is the charge on the bigger sphere? So much charge is flown from the smaller sphere. So that is what we want to find out. Bigger sphere charge is taken as Q2, therefore Q2 to be estimated. Now, so from the above equation 1, we can write 1 by 4 so it cancels there and R cancels there. Q2 equals 2Q. Q2 equals 2Q1. Now, so Q equals Q1 plus Q2. Substituting for Q2, we can write Q1 plus 2Q1 is Q, therefore Q1 is Q by 3. That means only 1/3 of the charge remains there. Therefore, charge flown onto second conductor is Q minus Q by 3, which is 2Q by 3. Option 4 is correct. Option 4 is correct. Now going for the 10th question here. A small conducting sphere of radius R lying concentrically inside a big hollow conducting sphere R. So that means these two are like this. We imagine this is R and this one is smaller. The bigger and smaller spheres are charged with capital Q and small q respectively and are insulated from each other. The potential difference between the spheres will be, say here in answering this question we need to use two concepts. For bigger sphere, the potential is due to two things. One due to its own charge capital Q and one due to inner sphere. And observe, the potential due to its own charge on the surface is given by 1 by 4 pi epsilon naught Q by R. And potential due to inner sphere is given by 1 by 4 pi epsilon naught Q by R. Because potential due to a sphere is nothing but the charge 1 by 4 naught charge divided by distance from the center. For any point on the bigger sphere, from the inner sphere distance is R, so this is potential of bigger sphere. In this same manner, potential of the inner sphere, observe, potential of the inner sphere means at any point on the inner sphere surface, the potential due to bigger sphere is 1 by 4 pi epsilon naught Q by R again, plus due to inner sphere, its surface, 1 by 4 pi epsilon naught Q by R. This is V small sphere. We are asked to calculate the potential difference. We take V small minus V big. If we subtract these two things, as you can see here, 1 by 4 naught Q by R cancels, and what we left with is 1 by 4 pi epsilon naught Q by R minus Q by capital R. So in the options, fourth option is correct. Fourth correct. So, in fact, this is the basic idea of Van de Graaff generator. Now we proceed on to next question, 11th one, which is also very easier. No question of calculations required. We read. There is a uniform electric field intensity E, which is as shown. How many labeled points have same electric potential as fully shaded point? Say this is fully shaded point and these are the points. This is the electric field. We know in any electric field, the equipotential surface or line is always perpendicular to electric field. That means all these points in a single vertical line are having same potentials. This first line from the left, what I am showing now, is having some potential. Second line is having same potential, all these 4 points. Third is also. But now we are asked for the shaded point, so only these things. So there are, apart from shaded, there are 3 points. So option 2 is correct. Because all these along with the shaded and remaining 3 have same potential, they are on the same line. Now going for the 12th question. A small oil drop of mass 10 raised to minus 6 kg is hanging at rest in between 2 plates separated by 1 millimeter having a potential difference 500. The charge on the drop, say it is to write the small simple figure, there is a small drop with charge Q and it is suspended between 2 plates where the electric field is applied. It is potential difference 500 volt applied and the separation is 1 millimeter D given. So in this case, as charge is at rest, its weight is balanced by electric force. That means mg equals E into Q. We are given with M, we are given with G, we are given with E as E equals say v by d, dv by dx, from that v by d we can write. Therefore, mg v by d into q, q equals mgd by v. We substitute everything. M 10 raised to minus 6, G 10, D 1 millimeter means 10 raised to minus 3 by V potential 500. So if we simplify all these things, say power is 1 0 goes there, 10 raised to minus 6 minus 3 minus 9 minus 1, so 10 raised to minus 10.2 it amounts to be, or 2 into 10 raised to minus 11. So option 2 is correct. Option 2 is correct. Going for the 13th question, it's also very simple. An uniform electric field in the plane of paper as shown. Here A, B, C, D are the points on a circle, V1, V2, circle, V1, V2, V3 are the potentials at those points respectively. Then what is correct here? We think over that. Say electric field is like this downwards. 4 points A, B, they are on same line perpendicular to that. C and D are here. We know, as we just now discussed, in the direction of electric field potential decreases. So C must have the highest potential, and A and B, as it is seen from the figure, they are on the same line, so their potentials must be same, and D is having smallest potential. So in the option 1, V1 is equal to V3, that's not possible because V1 is this one, V3 is this one, that's not possible, so that option is not there. V1 is, so second option is also gone. In the third option, V1 is greater than V3, that is correct. V2 is greater than V4. V1 is greater than V3, that is wrong because V3 is larger than V1, so third option is wrong. V1 is equal to V2, definitely A and B. V3, in fact here a symbol is missing, which is greater than. Say V3 at C is greater than D, so fourth option is correct according to the argument. Please remember always in this type of diagrams or in this type of electric field intensity ideas, always the potential decreases in a steep manner in the direction of electric field. A very important thing to be remembered. Now going for the 14th question. 3 charges minus Q plus capital Q and minus Q are placed at equal distance along a straight line. If the total potential energy is 0, then the ratio, say we write the figure like this. This is a line, I have minus Q here and another minus Q, and they are equidistant, means at the center I can have plus Q. It may be in any manner. Now the potential energy, we know how to write. Potential energy U is written as 1 by 4 pi epsilon naught. Say if I call it as Q1, Q2, Q3, then Q1, Q2 by, this we call as R12, this we call as R23, and this is R31 or R13. Now we write R12 plus Q2, Q3, R23 plus Q3, Q1, R31. This is the total potential energy of the system. Now we substitute everything. 9 into 10 raised to 9. What is not required? Left hand side is 0 as it is given. Q1 is minus Q into capital Q divided by R12 is R by 2 I take, because R13 has total R. Equidistant means, say we can take this as R and this has also R, and this is 2R. R31 is 2R. Now we substitute everything. Say minus QQ by R, R12 is R. Now RQ2, Q3 minus again QQ by R23 is also R, plus Q3, Q1 minus into minus plus Q into Q divided by R31 is 2R. We can take total R distance as R between minus Q and then we can do R by 2. That's what I started, but that's not required. You can do. Take total distance as 2R, and the minus Q2 plus capital Q is R, and this is also R as I showed. Now, with all these things, observe we can simply write here minus QQ by R and minus QQ by R, 2Q by R. So I can simply write 2QQ by R is equal to QQ by 2R. Now we cancel 1 here and this R here. What we are asked to calculate the ratio Q by Q, I can write as 1 by 2 into 2 is 4. So third option is correct. Third option is correct. 1 by 4.